Hi, I'm Arlene, and today we will be solving compound inequalities with and or. Compound inequality. A compound inequality is more than one inequality, and how they interact. Okay, so there are and inequalities, and there are or. So for and inequalities, you want both of them to be true. Okay? And for or, only one needs to be true. It's fine if both are true, but only one needs to be true. So for example, if I had a graph here and it went like, example, here and then here, then anything in this range would both be true. Or for example, if I had like this like this, and then this went like this, right? Only the second inequality's values would be true, because for the first inequality here, there would still be this gap here that wouldn't make the second one true. And there's another way, is if you have this and it goes like that, and it goes like that, then that's no solution for and inequalities. And also if you have a thing that goes like this and a thing that goes like this, then only the middle area here is the solutions. Now for or, you only need one to be true. So for example, if I did this and this, it would work for or, because you only need one of them to be true. So the solutions could either be these or these. And if I did it like this and then this, the solutions would be anything from these solutions. Like these solutions would also work, but if it was just this, then like these values here would also work. Okay, so let's solve for these and or inequalities. And now in the end, we're going to write the answers in set builder and interval notation. So first, if I simplify both of them, then negative 4x is greater than, and then I move this over, is negative 4, and then x is less than 1. And negative 4x is less than 8, x greater than negative 2. If I draw a number line to do like 0, 1, and 2, and negative 1, negative 2. So to graph both of them, I would do x less than, and then the other one is x is greater than this. So here, the values that would be the solutions are these values in between that overlap. Okay? So if you look at it, it starts from negative 2, but it's not negative 2, because negative 2 is not included in the solution here. And here, it ends at 1, but 1 is also not a solution because it's an open circle too. Okay, so for the values in interval notation, be negative 2, 1. And for set builder, you could, if you put these two together, it would be negative 2 is less than x, which is less than 1. And then, so this is exactly the final set builder thing. So for the set builder notation, it would be x such that negative 2 is less than x, which is less than 1. And that would be the set builder. Now for this or question, 5x is greater than 15, x is greater than 3, or 6x is less than 12, x is less than 2. Okay, and then you can draw a number line. 0, 1, 2, 3. Negative 1, negative 2. Okay, so 1 is greater than 3. And the other one is less than 2. So, or, right? So, this inequality, all the solutions, okay, all these solutions would be true, and all of these would be true. Okay? So for interval notation, for the x is less than 2, it could be negative infinity, 2, 2. And for the x is greater than 3, you could do 3, comma, infinity. And since there is a space between here, to connect these, you want to use a U shape. And this is called a union. Okay? First one is put that on the left range, on the left. And you want to put those on the right, like the larger solutions in a sense, on the right. That's how you do interval notation. Now for set builder, what you want to do is, really you just put an or in between the two inequalities, right? So you do x such that, okay, x is less than 2 or x is greater than 3. Okay. Now this is an extra question. It's not really a related topic. It's but I think it's a good challenge question. So negative 5, solve for the range of solutions of x when m plus 3 at times x minus 2m minus x is greater than 0. Okay. So if I want to move the 2m and the 6 to the other side, I would do a m plus 3 times x is less than 2m plus 6. Okay, and then here you see both of these have a 2 and is a factor. So you can factor it out. M plus 3 times x is greater than 2 parentheses m plus 3. Okay, and now you have both sides with a m plus 3. Okay, so since you know that m is less than negative 5, right, then m plus 3 would have to be less than 0, because for example, less than negative 5, right? Even if it was negative 5, it would be negative 5 plus 3, and that would equal negative 2, which is already less than 0. So if m is less than negative 5, then it would be even more less than 0. Okay, so you all know that m plus 3 is less than 0. So what you want to do is move this m plus 3 over to this side. Now x, since m plus 3 is negative, right, and when you divide or multiply by a negative over the inequality, then you want to flip the symbol. So here x now less than 2m plus 3 over m plus 3. Okay, and then what you want to do is, you know that you can cancel out this m plus 3 and this bottom one. So cancel it out, and then x is less than 2.